This is our setup for determining the frequency dependence of dielectric constant. We have the main unit over here. It has a frequency counter. This is a millivolt meter AC having dual range, that is 200 millivolt and 2000 millivolt AC. We have also the provision of looking at the output waveform on a CRO. So this switch is for switching between the meter and the CRO. We have 5 different types of capacitor here, and here we have R4, which is the resistance. This is a 500 ohm spot, and over here we have a series resistance of 500 ohms and 1K, which is selectable by this switch. This is the frequency control knob, and this is the amplitude control knob, and here we can connect the CRO probe. This socket over here is for connecting the sample. We have 2 samples. One is the MLCC capacitor, another is the polypropylene sheet, which we have here in between 2 plates. This is the dielectric material. This is the manual. It is pretty detailed. We will just go through it before starting with the experiment. Here we have the theoretical portion. Next we have the circuit connection diagram. Here all the details are mentioned, that is C1, C2, C4, R3, R4, the values. This is the bridge balance condition which has been used. This is the procedure for doing the experiment, which has been explained in details. We have the observation and calculation table. For the polypropylene sheet, we have calculated the value of C0. And now with the change in frequency, the sample readings have been given. This is for reference purpose only. The values will definitely differ from set to set. And this is the graph that we are getting. And now using the MLCC capacitor, this is the reading that we are obtaining. This is for reference purpose only. And this is the graph for the same. Now let us move on to the experiment. We have got 2 probes over here. This is the BNC probe, which is used for connecting with the CRO from here. We will not use this now. This is for connecting the sample. Please make sure that you match the notch over here to the notch given over here for the proper connection. Just push it and connect it. We are using this sample, the polypropylene sheet, first. Let us switch on the kit. The output reading, let us take the meter reading first and then we'll move on to the CRO. Keep the capacitance at any value. Initially, keep the value of R4, the series resistance, at 0. Make sure that this dial is at 0 position before starting with the experiment. Let us start with a frequency of, say, 10 kilohertz. We can also do the opposite. We can start from 90 kilohertz and slowly decrease it. So we have a frequency of 10 kilohertz over here. You can adjust the amplitude with the help of this amplitude knob. This AC meter has dual range. Currently it is at 2000 millivolt AC range. You can also keep it at 200 millivolt AC to get accurate results. So I'm keeping the amplitude over here. Now I'm starting to change the position of R4, and as I can see, the amplitude is decreasing over here. So we will keep on changing it until we get a point where the amplitude is minimum, and we will note the corresponding reading of R4 with the help of this dial. So it has started to increase, as you can see. So let us move a bit back and just try to obtain the minimum position. Yeah, so 6.8 is the minimum value that we are obtaining over here. So we are getting a dial reading of, this is at 8 and this is at, is coinciding with 56. So the dial reading is 8.56, because after this the reading starts to increase. Okay, So we will again keep this at a lower value, and we will increase the frequency in steps of 10 kilohertz at least to get appreciable change in the value of R4. So we've kept it at 20, and now again we are changing the value of R4 to get the minimum value. So 7.6 was the minimum value. 7.5 is the minimum value. So we are getting it at 8.54. As you can see from the dial reading, it is at 8.54, after which it starts to increase. So as we increase the frequency, we are getting a reduction in the reading of the R4. Now we are again changing it to 30 kilohertz. So now we are again changing the value of R4. The amplitude is decreasing. So 8.7 was the minimum value, as we saw. No. So for this, the minimum value is 8.7 and the dial reading is coming out to be 8.52. So after this, if we increase, the amplitude is increasing. So like this, we will keep on increasing the frequency in steps of 10 kilohertz, and we'll note down the value for R4, for which we are getting a minimum value in the meter reading. Plot the graph. Now let us see the same thing with the help of a CRO. So now we will connect the CRO. For this, we are using this BNC probe over here. Make sure that this switch is in the CRO position. Connect the positive of the CRO to the positive pin and the ground to the ground pin. So as we can see here, this is the waveform. The switch has been kept on this at the CRO mode. The frequency is 10 kilohertz and the dial reading of R4 is at 0. So we start increasing the dial reading and we can see that the amplitude is decreasing. We will find out the minimum amplitude, after which it starts to increase. So the minimum amplitude is over here, and we will note down the corresponding dial reading from this R4 reading. We will again change R4 to obtain the minimum amplitude. This is the minimum amplitude over here, and we will note down the corresponding dial reading from here. That will be the reading corresponding to the value of R4. So this is for this sample. Similarly, we will use this MLCC capacitor and we will find out the minimum value of the amplitude of the waveform. This is at the minimum position, and we'll note down the dial reading for this. We'll again change the frequency in steps of 10 kilohertz and do the same process every time to get our readings. So this is how we do the experiment of frequency dependency of dielectric constant. After taking down the dial readings of R4, we plot the graph and we note the value of the dielectric constant and how it changes with increase in frequency. As you can see here, for the polypropylene sheet with increase in frequency, the dielectric constant is decreasing. The value of R4, the change in value of R4 will be very minute, so you have to note it carefully. And for the multilayer capacitor also, with change in frequency, the value of R4 is decreasing. So that concludes our experiment. for finding out the frequency dependence of dielectric constant.
Please subscribe to our channel for more such videos. Thank you for watching.